Welcome to this explainer. Whenever you're cleaning up a room, stocking shelves, or just trying to plan a family dinner, you've actually been doing math without even realizing it. Today, we're going to decode that hidden mathematical logic and show you how the natural way you organize your life is entirely rooted in foundational mathematics.
Here's our roadmap for today. We'll start with the power of grouping, then we'll define sets and elements, jump into subsets, explore union and intersection, visualize it all with Venn diagrams, and finally, look at sets in daily life.
All right, let's jump right into part one, the power of grouping. Take a second and think about your own daily routines. When you organize things, whether that's at home, at work, or even just picking things out at the market, ask yourself this really fundamental question. Can one item belong to more than one group? Keep that thought in the back of your mind, because the answer literally unlocks everything we're about to discuss today.
If you look at this random jumbled assortment, rice, fish, mango, a ball pen, notebook, pencil, apple, ruler, banana, and an eraser, I bet your natural urge is to organize them, right? Your brain immediately wants to separate the market goods from the school supplies. It's just this automatic instinct we all have to bring order to chaos.
Moving on to part two, defining sets and elements.
So whenever you organize household items, or perhaps you're sorting goods for inventory in a sorry store, you're actually creating what mathematicians formally call a set. A set is simply a well-defined collection of objects, numbers, or even ideas. The absolutely crucial phrase here is well-defined. That means there is a clear, undeniable rule for why those specific things belong together. And the individual items inside those sets, like the specific foods or the specific school supplies we were just sorting, those are known as the elements. Think of it like this. If a set is the container, the elements are what you actually put inside it. And in math, to show that these elements belong to a specific set, we write them neatly inside curly braces.
So, looking back at our earlier list, we can formally write our food items in set notation. Notice how we use a capital letter to name the set, in this case, set A, and we place all our food elements snugly inside those curly braces. So, set A equals rice, fish, mango, apple, and banana. It's clean, it's structured, and it's perfectly clear.
Okay, part three, subsets, sets within sets. Now, subsets happen when you single out specific items from a much broader group. If every single element in your new, smaller set can already be found sitting in a larger set, well, you've just created a subset. It's like finding a set hiding inside of another set. Let's make this concrete. Take a broad group, set A, which contains our meal options, rice, fish, chicken, and vegetables. Then we have set B, which just contains rice and fish. Because the rice and the fish from set B are completely 100% contained within the broader meal options of set A, set B is mathematically considered a subset of set A. Honestly, it's just like picking your absolute favorites from a big menu.
Right. On to part four, union and intersection.
Imagine we're planning a massive feast for two totally different people. If we combine everything both people want to eat into one giant master list, we're creating a union. The golden rule of a union in set theory is that we combine all unique elements from set A or set B, but, and this is important, any repeated items are only written once. I mean, we don't need to write rice twice on our grocery list, right? We just need to know it's part of the total combined choices. But what if we only want to cook the exact meals that both people actually agree on? We don't want the total list anymore, we just want the overlap. In mathematics, we call this the intersection. It is strictly the elements that are common to both set A and set B. It's the shared ground. So here is the absolute crucial takeaway. A union combines everything together into one big inclusive umbrella, while an intersection strictly isolates the shared common ground. Understanding this difference is exactly how we make smart, organized decisions, whether we're buying groceries for the week or managing really complex data.
Which brings us nicely to part 5, visualizing with Venn diagrams.
Because let's face it, just staring at brackets and lists of text can get a bit dry. A Venn diagram maps out the relationships between different groups visually. It uses overlapping circles to instantly show you what belongs where, which makes complex information incredibly accessible.
Here's how we build our visual map step by step. First, you draw your overlapping circles. Second, you look for the common elements and drop them right into that middle overlapping section. Bam! That's your intersection. Third, you put the unique elements into their respective outer circles. And finally, if you step back, zoom out, and look at every single item inside all the circles combined, you are looking at the union.
Let's actually put this into practice using a family favorites example. Say learner A loves adobo, rice, fish, and bananas. Learner B, on the other hand, loves rice, chicken, bananas, and mangoes. If we map this out, rice and banana are the shared favorites, right? So they would sit perfectly right in the overlapping middle section of our diagram, representing our intersection. The outer parts of the circles would hold the unique cravings: adobo and fish for learner A, chicken and mango for learner B. And if you read every single item across the whole board, that is your union: adobo, rice, fish, banana, chicken, and mango.
And finally, part 6, sets in daily life.
See, math isn't just a bunch of chalk on a board. It's a literal tool for life. Whether you're participating in a bar and get cleanup and separating plastics from papers, organizing common tools at your workplace, or managing the inventory in a sorry store, you're actively using set logic. Every single day, you're identifying elements, creating subsets, and finding intersections.
By taking the sheer chaos of the real world and translating it into structured sets, unions, and intersections, we empower ourselves to make highly efficient decisions. It helps us see the relationships between things clearly, which frankly saves us a ton of time, energy, and resources. So as we wrap up this explainer, I want to leave you with a little challenge. Look at your immediate surroundings right now. Whether it's the apps on your phone, the clothes in your closet, or the people in your community, what sets do you interact with daily and where is their intersection? Once you start looking at the world through this beautifully organized lens, you are going to see the mathematical logic literally everywhere. Thanks for joining me on this deep dive, and keep observing those brilliant structures all around you.